Hey guys, so today we're going to learn about inverses, specifically inverse functions. So we're going to be given a function, we're going to try to find its inverse. We're also going to prove that two functions are inverses of each other. So let's go through some definitions right now. First, one of the ways we can tell that a function is a function is because it passes the vertical line test. Okay. So, in other words, if you had the graph of it, it would only hit the graph. All vertical lines would only hit the graph lines. You can also say that for every x, there is only one y. Okay. That's how we verbally say it. Now, if you look at the graph, and yes, the vertical line test tells us if the graph is a function or not. If you do a horizontal line test and it works and it only hits once, that means that the inverse of it is also a function. Okay, so it's great just to look at one to know if it's a function or not, or if the inverse is a function or not. Okay, so an inverse of a function. The inverse of a function takes the output answer, performs some operations on it, and arrives back at the original function starting value. Okay, that's a lot, right? So in other words, what we do is we switch x and y, and then we solve for y. Okay, but y is then indicated as f to the negative 1 of x. So anytime you see this, you can automatically say the inverse of f of x. Now, if both the original and the inverse are functions, that is what we call a one-to-one function. Okay, that means that the inverse is a function. Okay, not all functions meet that criteria to have an inverse, which is also a function. So, however, if we restrict the domain, we then can have the inverse to be a function. And I have an example of a graph right now. Okay, this down here is an x squared, correct? X squared. It is a function. If I did vertical lines like we have right here, it will only go through the graph once. So x squared is a function, correct? Now, if we did the horizontal line test here, you see that actually it hits the graph twice, which means the inverse is actually not a function. So it's not one-to-one, but we can make it that way. What's happening right here is we're restricting the domain by saying, hey, you know what? I only want the x values that are greater than or equal than 0. Okay, so actually, I'm just going to look at this part of the graph, and now we have a one-to-one function. Our vertical line test works and our horizontal. So in some cases, we're going to have to restrict the domain to find the inverse. Okay, so let's do some examples. The great thing about the graphs and coordinates is when we do these to find the inverse, all we do is switch x and y. So on here, I'm going to put my x values and my y values, okay? So I'm going to start with the least x value, which I see here is -1, and it's at -2. My next point I see here at 0, -1, 1, 1, and 2, 5, right? Did I get my points right? Okay, so remember that this is f of x. To find the inverse function, that would be f to the -1 of x. This is how we write our inverse. What we actually do is we take all these values here and we switch x and y. So now this point is going to be -2, -1, -1, 0. That point 1, 1, we switched it, but it's the same, right? And then 5, 2. Okay, so I'm going to plot these points to show you what the inverse looks like, and then I'm going to show you a little trick. So -2, -1, -1, 0, 1, 1, and 5, 2. Okay, so this would be our inverse function of f. Now, like I said, I'm going to show you a little trick. I'm actually going to replot these points. I'm looking for a better pen right now. Replot these points on the original graph because I want to put something out to you. Let me get a red pen. Okay, so that was what? -2, -1, -1, 0, 1, 1, and 5, 2. Oops, that's not 5. Let's do 5, 2. Okay. Okay, you see how that looks? Do you see something that's kind of familiar? What does it look like? What is this f function and this f inverse have in common? Well, actually, what happens is the function and its inverse is a reflection over y equals x. Hence why we're switching x and y. So if we wanted to, I could draw, of course, my point right there didn't match up so well. Y equals x, and it should be a reflection over that y equals x. Kind of neat. But we are also going to do this algebraically. So here's what we do algebraically. The first step we do is we're going to switch our x and y. Well, change f of x to y. I'm going to go straight into it, okay? Change x and y here, and then solve for y. So luckily, earlier we solved for variables. So this should be a piece of cake, right? To get rid of, or to get y by itself here, the first step we're going to do is subtract 7 and then divide by 5. So subtract 7, divide by 5. And we weren't really dealing with y's before. We don't want to say y because there was y up here. We want to identify what this function is. And this function is the inverse of f. So we always rewrite our final answer as f to the -1 of x. And that equals x minus 7 over 5. So these two functions right here are inverses of each other. So we're going to try that out right now. Okay. All right, so remember, we're changing f of x to y right now. And then we're going to switch x and y. So right now we have x equals 1/3 y minus 8. Okay, now we're going to get y by itself. So the first thing we're going to do is add 8 to both sides. So x plus 8 equals 1/3 y. Now, a couple of ways. How do you get rid of the 1/3? Well, it's multiplication, so usually we divide. So I would think, oh, I'm dividing by 1/3. But we know in the past that dividing by a fraction is the same thing as multiplying by its reciprocal, and it looks a little bit better. So the reciprocal of 1/3 is 3. So we're going to multiply both sides by 3. Now, on the left side here, since I'm multiplying everything by 3, I'm going to show you that step of putting the parentheses in and having y here. Now we got to change that y to the inverse identity. I also like it. Sometimes I like distributing. This should be fine, but I like distributing a little bit more. So my answer is going to be 3x plus 24, got to distribute, equals, and then I have my inverse. Okay. Very good. So this is our answer right here. Okay, let's try it on the next one here. Remember, f of x is what we're going to think of as y. We're going to switch our x and y. So we have x equals the square root of 2y minus 3 plus 5. Okay, let's start working backwards. We got to move that 5 first. So we're going to subtract 5 from both sides. Okay, what's next? What's technically around y? Well, we have a 2, we have a 3, and we have a square root. So what do we get rid of first? We have to get rid of the square root. How do you get rid of a square root? You square both sides. So this is going to be x minus 5 squared equals 2y minus 3. Okay. Then I'm going to get rid of the 3 by adding it to both sides. I want to show my pattern, so I'm going to make arrows right there since I have a couple more steps. So x minus 5 squared plus 3 equals 2y. Okay. I'm going to do two things at once if you don't mind. I'm going to get rid of that 2 by dividing. And I'm going to change my y back into the inverse because y is actually the inverse, okay? So if you don't mind, I'm going to do this together. So I have x minus 5 squared plus 3. And moving that 2 by dividing everything by 2. And then instead of y, we have the inverse. And there's one more thing I want to talk about, because remember on this page right here, when we talked about this graph, we went to a parabola, we restrict the domain, we restricted to half of the curve. And so when we would do the inverse, you would get only half the curve. So it would still be a function. Well, I want to show you on this one right here. If we were to graph this right now, what would it be? Well, it would be something like this. Right? But if you look at a square is parabola, right? So we can't have both sides. So what you need to keep in mind here is that this is positive here. So the domain for this graph is x is greater than or equal to 3/2. Okay? And the range, and I'm just going to give it to you because this part right here could be 0, can go to 5 or 5 and above. So y is greater than or equal to 5. Well, the great thing about inverses, because everything switched, so does the domain and the range. So actually in this function, we're only going to be looking at the domain that x is greater than or equal to 5. Again, I said switch, right? So this range is this domain. This is not going to be a big concept I'm going to make you remember. I'm mostly focusing this year on finding the inverse function. But when we come to domain and range, a lot of it's going to happen next year. Unless you're in this situation where it already restricts it. Okay. So this one is restricting it because otherwise we wouldn't have a one-to-one function, right? This is a parabola like this. And if we did the inverse, we'd end up like this, and that's not a function either. So what we're doing is we're restricting the domain to x is less than or equal to 3. Now think of those values. You think of those values are less than 3. That means they're in the negative direction. Okay. So less than is in the negative direction. Positive is in the positive direction, or greater than is in the positive direction. Okay. This will help us demonstrate. Okay, let's change this. This is y. Okay. So we're going to switch this over. So we get x equals parentheses y minus 3 squared plus 4. Okay, let's get y by itself. First thing we're going to do is subtract 4. All right, next thing. What do we do first? Do we get rid of that 3 or do we get rid of that square? Think of a present. We can't get to our present, our y, until we unwrap it. So we need to get rid of the square. How do you get rid of the square? Take the square root. Now, this is where it gets tricky. Because when you take the square root, how many answers do you have? You should have 2. So that's plus or minus. And then we're left with y minus 3. Okay, couple things. Can we kind of do 3 things at once now? I'm going to move this 3 over, right? By adding it to both sides. You can add it to the end or add it to the front, considering I like adding it to the front because then I don't confuse if it's under the square root or not. So I'm going to add 3 to both sides. So I'm going to start with 3. Now, originally we have this plus or minus here, but what kind of answers do we want? We want it to go in the negative direction, which means we need to subtract, not add. So this is where both of the answers would come in, but we only need one. So according to this domain restriction, we need to be to the left, which is subtraction. Okay. And then, of course, instead of writing y, what are we going to do? We're going to write f inverse. Awesome. Okay, my favorite example. Tons of steps. Okay, if you guys aren't doing tons of steps with this, you're doing it incorrectly. So let's keep going with this, okay? So find the inverse of this irrational function, okay? So the first thing we're gonna do is switch our x and y, okay? So I have x equals 4y plus 3 all over 3y minus 1. What is a problem you see here? The idea, our goal right now is to get y by itself, but we have 2 y's. How are we going to do that? Okay, well, I'm not going to give you the answer yet, but we're only going to do the math that we know we can do. Right now, I see a fraction. So many of us don't like fractions. So let's get rid of the fractions. Remember, to get rid of the fraction, we multiply both sides by the denominator. So what I'm going to do here is multiply this left side by 3y minus 1. Okay, when I multiply the right side by 3y minus 1, they cancel, so I'm left with 4y plus 3. Okay, just to get rid of the fraction. A little bit better, but we still have 2 y's. What are we going to do? So again, the only thing I see right now is I see parentheses, and usually we don't have parentheses around. So what can I do next? I can distribute. So I'm going to distribute this x. So I get 3xy minus x equals 4y plus 3. Okay. Still have 2 y's. Well, here's our next step. What we're going to do is we're going to get all the y's on the left side and everything without a y on the right side. Okay, which means I'm going to add x to both sides and I'm going to subtract 4y to both sides. Okay, so this 3xy stays here. I'm going to move this 4y over by subtracting it. I'm going to move this x over here because it doesn't have a y. Remember, I'm putting all my y's on the left side. So I'm adding x to this side, and we already have a 3 that we're going to keep there. Again, I put all my y's on my left side, everything without a y on the right. Now, we still have 2 y's, but what can we do? Think about going backwards. What do they have in common? They have on this left side, what we have in common is a y. So we're going to factor out a y, leaving 3x minus 4. See what I just did? I factored out the common. I factored out that y, leaving us with, on the right side, x plus 3 still. Now, hey, we got down to 1 y, but now we need to get it by itself, right? So what is y doing to these parentheses? It's multiplying. So how do we get rid of multiplication? We get rid of multiplication by dividing. So we're going to have this x plus 3 all over 3x minus 4. And of course, we're not dealing with y's. We're really dealing with the inverse. Awesome. Great. Now we've learned how to find inverses. The next thing I'm going to do here is we are going to prove inverses. And I know it's a tedious task, but we need to learn how to say why this works. Okay. So it's not just saying, hey, let's find the inverse of 1. Hey, they must be inverses. No, let's prove that they are. And this is something you do in college algebra and the upper level courses. Okay. So here's the idea. We learned composition the other day, right? A function within a function, right? Well, the idea is this. If we take our inverse function and we compose it to our original function, they should get x if they're inverses of each other. But it's also the other way around. So you actually have to, for proving, you have to do both compositions to prove that they are inverses of each other. So when we compose one into the other, we should come out with the value of x. Okay. And when we do this, then we know that they are inverses of each other. So that's what we're going to do right now. We're going to prove. I'm going to do this. So g of x right here is actually what we're considering the inverse. Okay. And we're going to check out and see if they are inverses of each other. So on this side, I'm going to put g of x into f. And on this side over here, I'm going to put f of x into g. And then I'm going to do some algebra and see if it comes out with the value of x. Okay, so I'm going to start with f of x and I'm putting in g. Okay, so this means I'm going to have 3. Now, instead of x, I'm putting in the g function, right? So that's going to be x plus 2 all over 3. And then continue, you get minus 2. So see how this works right here? I look at the f of x function. This is the f of x function, but instead of x, I have the g function. Okay. Now, what can we do? Well, 3 divided by 3 is 1, leaving x plus 2 minus 2. Well, 2 minus 2 is 0, so leaving x. Now here, one thing I want you to get in the habit of, even though I just did it on the other page with 2 steps in a row, especially when it's like obvious that it's going to come to, you want to show your steps. So see how I just canceled out the 3's here and then canceled out the 2's. I want to show that step. I don't want to say this equals x because I'm not showing any of my thinking. Okay. And to get credit, you need to show your thinking. All right, and this one, I'm looking at g of x, but for every x I see, I'm going to put in f of x. So I see an x here first, so I'm going to put in f of x. And I have this add 2 all over 3. So again, this is my g of x function, but instead of x, I'm putting in f of x. Okay, so this one's a little bit different, right? So first of all, these parentheses don't need to be here. I just wanted to show you the f of x, right? So the first step I can do is cancel out these 2's, right? So that leaves us 3x over 3. Well, 3 over 3 is 1, leaving us x. What do you know? That means that these 2 are inverses of each other. So f of x and g of x are inverses. All right, let's check the other one. The other one, these look a little bit more complicated, so be careful on your algebra, because actually when I was doing this, I made a simple mistake. Okay, so let's do the same thing. Let's do f of g on this side. Okay, so I'm going to start with my f of x function. For every x I see, I'll put in the g. So I start out with 3. Now instead of x, I'm going to put x plus 5 all over x minus 3 plus 5. all over. Oh, there's another x, so that's x plus 5 over x minus 3 minus 3. No, minus 1, sorry. Looking at the f of x function. Okay, there we go. Now, first thing I see here, it looks a little confusing. Now, you could do one step before the other. I'm just going to do it this way so I can see it better, okay? So, the first thing I'm going to do is distribute that 3 on top right here. Now, remember, when you distribute this 3, this is 3 over 1. So, you're only distributing it to the x plus 5. So, we get 3x plus 15 all over x minus 3 plus this 5 all over still the x plus 5 time over x minus 3 minus 1. Do you guys see that? Okay. What's the one thing we hate? We don't like the fraction. It's crazy. So to get rid of that fraction, we would have to multiply by x minus 3. But we can't just multiply one side by x minus 3. We could multiply it by the value of 1. So instead, I want you to think of this as we're going to multiply each term by x minus 3 over x minus 3. Again, this is the value of 1. We can do that, right? Because anything times 1 is itself. Now, when you multiply the whole thing, you're multiplying all values or all terms, okay? So all of it. So this first one, when I multiply by x minus 3, they actually get rid of the x minus 3. So we're left here with 3x plus 15. Then here we have this plus 5, but we're also multiplying that by x minus 3 all over. This one gets rid of the x minus 3, so that's x plus 5 minus, now be careful, don't forget that's parentheses. This is 1 times this, so x minus 3. And be careful, that needs parentheses there. All right, so now I'm going to move over here so I have some room. I'm going to distribute. So we have 3x plus 15 plus 5x minus 15 all over x plus 5 minus x plus 3. All right, let's combine like terms. So on top in the numerator, we have 3x and 5x, which is 8x. 15 and negative 15 cancel. X and x cancel. 5 plus 3 is 8. And if we reduce that more, 8 over 8 is 1, leaving us x. Okay, we got to do the other way. So we're going to do g of f of x. Okay, bear with me. All right, so we're going to start with g. As you can see, I start with an x, so I need to put in f of x. So we have 3x plus 5 all over x minus 1. Now I finished the top off here for g is plus 5 all over. I start again with an x, so I have to put f of x in there. 3x plus 5 x minus 1 and then minus 3. So again, it looks like g of x, but wherever x we have, we actually put the function in. All right, this one here, we're going to do exactly what we did here, but instead, we're going to multiply it by x minus 1 over x minus 1. Okay, so that gives us 3x plus 5, right? Because that first term they cancel, plus 5 times x minus 1 all over. That term on the denominator, it cancels. So we have 3x plus 5 minus 3 times x minus 1. Because again, we're distributing this to each term. Okay. All right, let's distribute that -3 and that 5. So 3x plus 5 plus 5x minus 5 all over 3x plus 5 minus 3x plus 3. Right, negative times a negative is a positive. All right, on top, our 5s here cancel, leaving us with 8x all over. On the bottom here, our 3x's cancel. 5 plus 3 is 8. And again, 8 over 8 is 1, so we're left with x. Again, this tells us that f of x and g of x are inverses. Very good. Again, this seems tedious of why we have to prove it, but upper level math will make sure that you prove. And the way to prove inverses, that two functions are inverses, is to show the composition of both equal x. All right, let's do some practice.